Today we're going to talk about the empirical formula. So the skill that we want to have by the end is being able to use the percent composition of a compound to basically generate its formula. So the empirical formula is basically something that relates to the percent composition. Now the percent composition gives you the breakdown of the elements within a compound. Basically it tells you what percentage an element makes out of the entire compound. But if you're given the percent composition, you can actually generate the formula to figure out what the compound actually is. Now the empirical formula is basically the simplest whole number ratio of the atoms. So we know that formulae are essentially a ratio of atoms to each other within a compound. Take for example H2O with a 2:1 hydrogen to oxygen ratio, or CO2 with a 1:2 carbon to oxygen ratio. The empirical formula of a compound is the formula where the ratio of atoms of different elements to one another are in their simplest form or the simplest stage. Basically the most reduced form of a compound formula. Okay, so just a few things that can actually give you the percent composition, like instruments, basically like things that they use in a lab. They're called GCMS, which is gas chromatogram that uses mass spectrometry, or the HPLC, the high pressure liquid chromatography. These are basically just different things that if you run a sample of a compound through, it'll actually give you, based on analysis, giving you a breakdown of what's in it. So these are just some instruments here to help identify the percent composition of a compound. This is more of a practical sense. It's not really applicable unless you actually use it. Just kind of give you an idea of how you can actually get these percent compositions in the real world. So going through to find out the empirical formula, you need to have the percent composition. When you know the percent composition, basically the makeup of a compound, you can find out its formula through a few steps. So the steps to determine the empirical formula is, first off, you want to assume no matter what the percentages are, that you've got 100 grams of the substance. Because that way, if you have 100 grams of the substance, the percent composition of each element is going to essentially equal to the grams present of each element. Okay, we'll kind of see that in action here. Once you know how many grams of each element you have, you're going to want to turn those into moles, because that way when they're in moles, you have a much better and much more accurate idea of exactly how much of each element is present. Now, because our formula is a ratio of the atoms of elements to each other, you're going to basically find what that ratio is. So you're going to divide all the moles of all the elements by the smallest number of moles present there. Okay, this is basically going to give you the ratio of the elements to one another, and you're going to be dividing by the smallest one to ensure that the smallest number you're going to have is a 1, because you're not going to have 0.5 of an atom. You've got to have 1. It's all going to be whole numbers here. And if necessary, so this is not always going to be the case, but you may have to multiply all the final answers in order to get all of them to a whole number, because again, we're talking about atoms here. It has to be a whole number if we're dealing with atoms. Okay. This is a lot easier done than just kind of like reading or just said. So let's go ahead and practice here. So we want to determine the empirical formula of a compound that is 11.8% hydrogen and 88.2% oxygen. Okay, so step 1 says assume 100 grams. So that means no matter what this is, I have 100 grams of it. So if this thing is 88.2% oxygen and 11.8% hydrogen, I'm going to have 100 grams of this stuff. So if I have 100 grams and 88.2% of that is oxygen, well, that means I have 88.2 grams of oxygen. We assume 100 just because it makes this transition from percentage to grams easier. Of course, you can do this for any number of grams. So if you want to assume 50 grams, that's fine. You're just going to have to do the math a little bit. 100 means just percentage equals grams. That's why we assume 100 grams, just to make our lives easier. Okay, so if I've got 100 grams of the substance, okay, 88.2% oxygen, 11.8% hydrogen, I have 88.2 grams of oxygen and 11.8 grams of hydrogen. So because grams is basically arbitrary, does not tell me much about how much I actually have, I'm going to go ahead and turn these into moles. So we're going to essentially multiply by 1 over the molar mass, so 1 over 16 grams of oxygen times 1 mole over 1.01 gram of hydrogen. Okay, so my 88.2 grams of oxygen is actually 5.51 moles of oxygen. And my 11.8 grams of hydrogen is actually 11.68 moles of hydrogen. Okay, so now I know how many moles I have. So even though I had like 88 grams of oxygen, okay, I still have so many more moles of hydrogen because this mass kind of really makes a difference. So now I know how many moles of each element I have to one another. I'm going to take the ratio. So I'm going to take the smallest number between the two, 5.51, and I'm going to divide both by it to basically get a ratio. Okay, so this one comes out to 1, this one comes to about 2. So what this tells me is for every 1 oxygen in my compound, I'm going to have 2 hydrogen. So that means my compound formula is H2O. I have 2 hydrogen for every 1 oxygen. And there you have it. These final numbers basically tell you how many atoms of each element are going to be present in your compound. And again, this is the simplest whole number ratio, so now I have an idea of how many atoms of each element are present in it. So H2O here. Okay, so let's move on to another type of formula called the molecular formula. So what we want to be able to do is take the empirical, the simplest whole number ratio, and turn it into what's called the molecular formula. So the difference is that the molecular formula is the real, true formula of the compound. So although the empirical formula is the simplest, basically reduced version of it, it may not be correct, because even though the ratios may be the same, having a different number of atoms does actually change what the compound is. So the molecular formula is the real or the true actual compound formula here. So because the empirical formula is essentially, it's like a reduced form of the molecular formula, you're going to have to find what the scale factor is. So the scale factor, or basically like the relationship between the two, is just taken by the molar mass of the two types of compounds. So if you know the molar mass of the actual compound and the molar mass of the empirical formula, you can figure out how they're related, what the scale factor is, and that's how you can kind of turn your empirical formula into your molecular formula. Sometimes they happen to be the same thing, not all the time. Okay, again, because the empirical formula is the most reduced version, it just so happens that sometimes that's what it really is. So again, this is probably easier said done, easier done than said. So let's take a look here. So we have an unknown hydrocarbon that contains 85.7% carbon, and this hydrocarbon has a mass of 84 gram per mole. So we want to know what the molecular or the true formula is. So the only thing that we know, the percent composition of carbon, which is 85.7%. Well, we know it's a hydrocarbon, so that means there's carbon and hydrogen present. So if it's 85.7% carbon, that means it's got to be 14.3% hydrogen. Okay, so from this, we can actually determine what the empirical formula is. We just kind of did that before. So we're going to assume 100 grams here. So we're going to assume I have actually 85.7 grams of carbon and 14.3 grams of hydrogen. Okay, we're going to have to convert these into moles. So once again, we're just going to go ahead and divide by the molar mass in both instances. Okay, so I'm going to have 7.13 moles of carbon. I'm going to have 14.15 moles of hydrogen. Now that I have moles of each, I'm going to divide by the smallest number in both cases. Divide by 7.13. Divide by 7.13. Comes out to 1. This comes out to 2. Okay, so again, I'm going to have my empirical formula as a 1 to 2 ratio. I'm having 1 carbon and 2 hydrogens in it. So this is the empirical formula, which means it is the simplest ratio, or the reduced formula here. So my compound has a mass of 84.0 grams. Okay, this thing has a mass of just 14 grams per mole. So we have to figure out, okay, this real formula, this molecular formula, was reduced a few times down to CH2, and this thing only has a mass of 14 grams. So let's see how much it was reduced by. It should have a mass of 84. This formula has a mass of 14. Well, that's 6. So that means this formula is basically 1/6 of what it should be. So I have to multiply everything by 6. So it's C6H12. I still have that 1:2 ratio that we got from here, but C6H12 and CH2 are two completely different things. This is the true or the molecular formula of the compound. This is what the compound really is. It's not CH2, it's C6H12. So even though the ratio is the same, these are two completely different things, which is why we needed the molecular formula, because that gives me the true formula. Now we know exactly what we're dealing with. Okay, so finding the molecular formula, you must know the empirical formula, and you have to know what the actual atomic mass of your compound is.